time to those who ate. Let's talk about some allowances. Does anybody even get an allowance anymore?
No.
No.
I just have to do right.
Then I wouldn't have no job.
Right?
You get $5 a week being on.
Yeah.
You used to get like a mom or dad bus or some crap like that.
Who did?
Pitchy.
Alright.
Something like that.
So Allison and Beth each received $10 per week for doing chores for their neighbor. One day Allison decides to try and increase her income using her knowledge of exponential growth. She proposes that her payment be changed to a penny and then doubled each week thereafter. So Allison's like, you know what, you don't have to pay me $10, pay me a penny, but each week double my pay. That's what she's saying right there, okay? So complete a table to represent, go ahead and work on the table to fill out how much each person's going to be getting up to 8 weeks, okay? Alright, so week 1, Allison's going to get a penny, Beth is going to get $10. Week 2, how much is Allison going to get? 2 cents, right? How much is Beth going to get? Still getting $10. Finish that. Alright. Okay, so let's talk. So, week 3, what's Allison making? 4 cents. And week 4? 8 cents. And week 5? And then week 6? $1.28. And then over here, Beth is like, exactly. She's getting some money, right? So how does Allison's income change as the number of weeks increase?
It's double.
It doubles. Multiplies by 2, right? Okay. Multiplies times 2. Alright, now we're going to talk about, we got 2 words here that I'm not sure that you remember from Algebra 1. So I'm not sure if you went over them in Algebra 1. And that's all we're going to say about that. Okay. It would be great if that would erase. Thank you. I'm just not sure where everybody, like, how did you go here for Algebra 1? You may not have, you never know your background. Okay, so, does Allison's income represent an arithmetic or a geometric sequence? Okay, so for the arithmetic, that means you're adding the same thing all the time. Okay? You're constantly adding the same amount. Like, if you buy 1 Cadbury cream egg, it's 89 cents. If you buy 2 Cadbury cream eggs, then it's $1.88. If you buy, or $1.78. If you buy 3, it's 89 times 3. If you buy 4, so that's arithmetic because you're adding 89 cents for every Cadbury cream egg. Okay. A geometric sequence means that you don't increase by a common amount, you increase by a common ratio. Every week it doubles. So that's a geometric sequence. Because every week it doubles, it doubles, it doubles. There is something in common, right? It's times 2 every week. I'm not adding the same amount. Stop. I'm increasing the same amount. I'm increasing times 2. So that's a geometric sequence, okay? So what would the general formula be? What would the general formula be? We started out with what amount? 1 penny. Okay. And then it doubled every week, right? So we took her original amount. I'm just going to call it A for right now. Okay. Her original amount, and we multiplied it times 2. But we didn't just multiply it times 2, because that would give you the same thing every time, right? So look at your chart. How much did she get week 2? 2 cents. So basically 1 times 2. How much did she get week 2? Week 3. 4 cents. So 4 cents would be like her original amount times 2 times 2, right? So we had the original amount times 2, and then we had the original amount times 2 times 2. This is week 1, this is week 2, this is week 3. So week 4, she had the original amount times 2 times 2 times 2. I'm guessing it was 8 tenths. Okay. And then the 5th week, it would be, we had to double it 4 times. So what's happening here? How are we determining how many times? Like if I said, well, what's week 18 going to be? How many 2's are going to be there on week 18? How do you know? There's one less, right? So we're taking the original amount times 2 to the number of weeks minus 1 power, right? Because on week 2, it was just 1 2. On week 3, there were 2 of them. On week 4, there were 3. And then you just told me on week 18, there would be 17 2's, right? Okay. Good. We just did that. Like, I think we just answered 4. Oh, it wants her exact. Okay, so she started with 1 cent times 2 to the n minus 1. That's our exact representation for her income right there. So, does everyone see where we went with this? Okay. I'm going to erase it because I want to go to the next page. Everybody got it? Think it'll work? Yep. Did you get to the part in Princess Bride where it said, think it'll work, where they saw Miracle Match? You think it'll work? You think it'll take a miracle. Alright, so number 6. If the pattern were to continue, how many weeks would it take for Allison to have a larger weekly income than Beth? Complete the table. So what week did we stop at? So let's do 9, 10, and 11. So Beth, we know, is still going to be getting $10. On week 9, how much is Allison going to get? 66. On week 10, how much is she going to get? 512. Week 11. Alright, so on week 11, she's starting to make more. On week 11. Alright, you can write in the explicit formula for the geometric sequence. You can write the explicit formula for geometric sequence a sub n equals 0.01 times 2 to the n minus 1 in function notation using the properties of powers. So this basically, and here's what they've done. Everything sort of that we did in the last chapter. Rewrite it in function notation. Use your product rule. And then 2 to the negative 1 is 1 over 2. 1 over 2 times 0.01 is 0.005. So this, in function notation, is the same as 0.005 times 2 to the n. Now, I want to go ahead and work that out because I just don't think that watching their, or just reading through their steps would help you that much. Okay, do you remember the rule, the product rule? If you have the same base and you're multiplying them together, what you could do? Like if I have x to the 8 times x to the 6, what can I do with that? Right, that's equal to x to the 8 plus 6, whatever that is, right? So that's what they've done here, except they've gone backwards. They said, oh, well, they subtracted that, so it must have started out as a multiplication problem. So this had to be 0.01 times 2 to the n times 2 to the negative 1. Because I have the same base, so if I have the same base, it would just be, I'd add them together. 1 is negative, so it's going to be n minus 1, but still I'm just going to put them together. Okay, so that's what they did first. That's what they did when they said product rule. That's where that product rule came from. You remember about negative exponents? Not allowed. Negative exponents have to be flipped, right? So that's 0.01 times 2 to the n times 1/2. And then this is just multiplication. 0.01 times 1/2 is 0.005 times 2 to the n. Okay? That's how they got from here to here. Here to here. Okay? And I know it's written in your book, but I just really feel like it helps a lot if you see it happen instead of just reading it in your book. Okay? Alright. Questions about that? Look at answer numbers 7, A, B, and C on the next page. How much money is Allison going to get her 15th week? $163.84. Right. We're going to have 0.005 times 2 to the 15th. 163.84. How about her 20th week? 5,242.88. Basically, you're looking for F of 20. Say 20 and then write 19. Alright, what was it? 5,000? If you're using the function notation, you don't have to subtract the 1. Yeah. If you're using the other one, then you have to subtract the 1. But if you're not, then you don't have to. And then in the 24th week, how much money does her neighbor have to pay her? Exactly. So, not a bad deal. Yeah, for a summer job or something, that's not too bad money to picking up. Yeah, the poor old neighbor. It's what? Alright, so predict the shape and the characteristics of the graph. What is this graph going to look like? If I'm graphing these points, if these are weeks, and this is money, what is this graph going to look like? Yeah, it's going to kind of start slow, but then when it speeds up, boom! Yeah, it really goes for it. It does not play around, right? Yeah, it shoots up there. Exactly. Alright, let's look at the graph on the next page, the tortoise and the hare. So, Beth is amazed. She's like, what the what? Yeah. So she decides that she wants in on the action, and she asks her two friends, Quentin and Alicia, to help her come up with a plan. And Quentin says you should start with $1 and ask for 50% more each week. Alicia says you should start with $1 and add another $1 each week. Whose plan should she use? Alright, well, let's see. Alright, so let's start with Quentin's plan. And actually, both plans on the first week 0, they get $1, right? $1.50? Okay. No, not $2. He's not asking for 50 cents more. He's asking for 50% more. Oh, Alicia, yeah, Alicia's going to be $2 over here. Let's do one and then the other. What's 50% of $1.50? 75 cents. So that's going to be what, 225? Okay. Week 3. What's 50% of 225? About $1.12. By the way, you can do this in your calculator. 225 times 1.5. That gets you 100% of what you already earned plus 50% more, 1.5. Okay, so when you put 225 times 1.5 in your calculator, what do you get?
3.375.
What?
3.375.
375? That's good. Okay, so now, week 4, 3.38 times 1.5. Happening in week 4.
Oh, we cool. 5,
And
7, 6, 61.
71.
11 what?
43.
And week 7?
17, 11.
17, 11. Alright, so she's just going to
I
have
got
3.
17, 13.
That's what I got. Week 4 is 507.
Alright, there we go. That's what we got. So whose plan should she choose? Quentin's plan. Quentin's plan. Alright, see, this, you're adding the same number. This is arithmetic. Plus 1, plus 1, plus 1, plus 1. That's your slope. Your slope is 1. It increases by 1 each time. This is geometric. Okay? It's increasing over time. You could graph it out, and Alicia's plan would look pretty much, there's 1, 2, 3. Oh, sorry. I'm off one. Week 2 is 3. I'm not a good grapher on here, by the way.
Draw a line.
So it's going to look something like that. And then, see, Quentin starts with 1, put by week 1, and 50. Week 2, you're 225. Week 3, 8. Week 4, week 6, you're up here at 7. So his comes in and does like this. Way better rate of return, right? Y'all could probably graph that much more neatly on your page than I can graph it. Okay. Alright, we're going to try and talk about one more thing. A half-life. Skip over to problem 3 on 745, and let's talk about a half-life.
I have a half.
You have half of a life?
Yeah. I got 30.
I don't know what page it is. It's problem 3.
745.
This eraser won't even follow.
1738.
Alright, right there. Half-life of caffeine. Alright, so a half-life is the amount of time it takes for a substance. Okay. This guy has his Big Buzz energy drink that has 80 milligrams of caffeine, and the half-life is 5 hours. So after 5 hours, how much is left? It's a half-life.
A third of it.
40 milligrams. Can see how 40 is half of 80? See that? Okay. So, here's what's happening. After 5 hours, 40 milligrams are left. After 10 hours, so another 5 hours have passed, how much is left? 20, right? Okay. So, let's just see. Caffeine starts out at what? 80? There have been no half-life cycles. Then after 5 hours, it's down to 40. That's one half-life cycle. After 10, it's at 20. That's 2. After 15, we're down to 10. That's 3. and then it's down to 4. All right? What's the rate of decay? What's the name of this? What's the rate of decay? Half. Every 5 hours. All right. Half for every 5 hours. So we're multiplying by half, and how often are we doing that? Every 5 hours. Okay. Me and this eraser are about to go round and round. I'm just saying. All right, so Emily's right, Tyler's wrong, and Renee's wrong. What's different here? Emily said we started with 80, we took half. How many times? Well, it depends on how many times 5 hours had passed by. Tyler and Renee, what's up with Tyler's here? What does he have? A negative. That's not right, Tyler. What's up with Renee? What did Renee do? Hello, is Renee losing any caffeine here? No. She's getting like 5 tea. Yeah, we're getting more. Yeah, she's actually probably has like an IV of caffeine going directly into her arm. Yeah. All right. So, no. What's wrong with this one? There's no half. Yeah, we didn't get rid of half of it. We didn't multiply by half, okay? So that's how a half-life works. You're multiplying by half. Basically, you take your initial amount times 1/2 to how many times your half-life has passed, or how much time has passed over the amount of time in your half-life. Because not everything has the same half-life. Okay, not everything's out of your system in 5 hours. Divide by. Okay, some things last longer. All right.